Welcome students to session 3 of physics, chapter number 2, units and measurement. Till that we have studied various fundamental quantities, various derived quantities, and we have seen that there are total 7 base quantities, and we have studied the units for the same. Now moving to the next important topic of this chapter, that is dimensions of a physical quantity. Dimensions of a physical quantity. Now before moving into this topic, let me clear what do you mean by dimensions. There are 7 dimensions of the world. 7 dimensions of the world. All the derived quantities, all the derived physical quantities can be expressed in terms of some combinations of the 7 fundamental or base quantities. You can express any derived quantities in terms of the 7 fundamental or base quantities. We call this fundamental quantities as the 7 dimensions of the world. The 7 quantities are known as 7 dimensions of the world, which are denoted with the square brackets. Like this. The very first quantity that we have seen, that is dimension of length. Dimension of length will be denoted by the square bracket. Inside you will put L. Clear? Second, dimension of mass, that you are going to denote by the square bracket capital M. Third dimension, that is dimension of time. Dimension of time is given by square bracket capital T. Fourth quantity, dimension of electric current. Dimension of electric current, that you are going to give by letter capital A, because it is named after scientist. Next, dimension of thermodynamic temperature. Dimension of thermodynamic temperature, you are going to denote by capital K. Clear? Sixth, because it is again named after the scientist Kelvin, that's why it's capital K. Next, dimension of luminous intensity, named after scientist Candela, CD. Seventh, dimensions of amount of substance. Dimensions of amount of substance. This quantity is also known as quantity of matter. Quantity of matter, that is one and the same, given by square bracket mole. Remember, the unit mole is written as MOLE, whereas the dimension is written as square bracket MOL. The next topic, that is dimension of a physical quantity. Dimensions of a physical quantity. Now, what is exact dimension of physical quantity defined as? The dimensions of a physical quantity The dimensions of a physical quantity are the powers bracket, or you can say exponents, anything, something to be at the raise of someone, that is nothing but exponents, to which the fundamental quantities must be raised in power of, to represent that quantity, For example, we can say, if I take example of density is what? Mass upon volume, that everybody knows. Mass is fundamental quantity, volume is derived quantity. This is what? Derived quantity. This is what? Fundamental quantity. Yes or no? Derived quantity can be further divided into what? Base quantities. So volume can be written as what? Length into breadth into height. Yes or no? So dimensions of density is given by, for mass you can write capital M, for length you are going to write L, for breadth L, for height L. All are the units of length only. Yes, so your answer is what? Capital M above. 1 1 1 will lead to how much? L3. So my final answer is M1. L3 is in the denominator. If you move to the numerator, it will be -3. There is no specification for time, so will be 0. So dimensional formula for density is M1 L minus 3T 0. Hence the dimensions of density are 1 in mass, -3 in length, and 0 in time. Hope it is cleared. Moving further, dimensional formula and dimensional equations. This is the next topic. Moving ahead, what is exactly dimensional formula is? Dimensional formula, the expression which shows how and which of the fundamental quantities represent the dimensions of a physical quantity is called dimensional formula of the given physical quantity. Hope it is cleared. It is saying that the expression which shows how many of the quantities are being related in order to define the physical quantity, and which of the fundamental quantities and how much to the power are representing the given fundamental quantity will give you the dimensions of the physical quantity. Clear? Example, we can take volume. I can take an example like volume. Volume is represented by what? Length into breadth into what? Height. Yes or no? Length L, breadth is again L, dimension of length, height is again dimension of length. So I can get what? L 1 1 1 1 plus 1 plus 1 is how much? 3. So my dimensional formula, there is no mass. L3, there is no time, so 0. Clear? Next is dimensional equation. Next is dimensional equation. The equation, what is dimensional equation? The equation obtained by equating a physical quantity with its dimensional formula is called the dimensional equation. The dimensional equation of the given physical quantity. I can give you the example for force. What is for force? Mass into acceleration. Everybody knows that force is what? Mass into acceleration. Clear? So mass will be what? M. Acceleration, again you have to think about it. What is acceleration? It is meter per second square, right? For the acceleration you can use meter per second square, and for mass you are having kg. For kg, that is M, meter, that is L, and second is what? T square. This is how you can make from the unit, that is length L, time T square. So up, that is M1 L1, down you are having T square, but M1 L1, this T will come up and power will become minus. So your answer is what? M1 L1 T minus 2. Till this clear? If I can give you example of area. Again, what is area? That is length into breadth. Yes or no? Length into breadth. So for the case of length you will put L, for the breadth you are going to put L. So your answer is what? L2. More precisely I can write as M0 L2 T 0. There is no mass and time, so you have to put 0. So here in the case of area I can write what? L into L. So I am going to get what? L2. But you have to represent in 3 terms of quantity, in 3 quantities term, therefore it's M0 L2 T 0. This is the dimensional formula for area. This is the dimensional formula for force. Hope it is cleared. Fine. So now we are going to see some physical quantities, their relationship with other physical quantities, what is the dimensional formula, how dimensional formula is extracted, what is the SI unit, that we are going to see for some of the fundamental quantities that you have to prepare for the exam. They might ask the objectives from these quantities. Clear? So moving to the very first quantity, that is area. What is area actually? Area is nothing but what? Length into breadth. Yes or no? Area can be represented by what? Length into breadth. If I want to derive dimension, for length I have L, for breadth I have L, so I have L square. I can write, there is no mass, so M0 length L2 T 0. Till this clear? And for the case of length you are having meter unit, for breadth you are having meter unit, so my final unit for area is what? Meter square, and dimensional formula is M0 L2 T 0. Hope it is cleared. Moving to the next quantity, that is volume. For the case of volume, what is the relationship? That is length, breadth into what you are having, height with you. So for the length you are having L, for the breadth you are having L, for the height you are having L. So my total is how much? L cube. For the mass, it's independent of mass, so m0. Length L3, it is independent of time, so t0. Unit for length is meter, for breadth is meter, for height is meter, so unit will be what? Meter cube. Hope it is cleared. The third quantity, that is density. Density is always defined as what? Mass upon, expressed as mass upon volume. Now remember, mass m, volume already derived, that is L cube. So my answer is what? M1. L, this 3 will go up, then it will be minus 3. It is independent of time, means T0. This is my dimensional formula. For the unit, mass is measured in kg, volume is measured in meter cube. So my unit is what? Kg meter cube, can also be written as kg meter minus 3. Why minus 3? Because this 3 will move up as minus 3. So I can write kg meter minus 3, or I can write kg per meter cube. Next is speed or velocity. Speed or velocity, we already know that what is the formula for speed and velocity, that is distance traveled per unit time taken. So for the distance you are having L, for time you are having T. It is independent of mass, with m0, L1. This T will move up, so it will be T minus 1. This is my dimensional formula for what? Speed or velocity. Unit for distance you are having meter, for time you are having seconds. So unit will be what? Meter second minus 1, or you can say meter per second. Hope it is cleared. Next is acceleration. What is acceleration? Acceleration is nothing but what? Change in velocity upon time, you can say. Change in velocity upon time. Change in velocity, you have already derived the formula for velocity, that is how much? m0 L1 t minus 1 divided by time is t. Again this t will move up, so it's m0 L1 t minus 2. Minus 1 was already there, this t1 will move up, it will become minus 1 minus 1 minus 1 minus 2. Unit change in velocity is meter per second. Sorry, time is in second. This second and second will move down, so it will be meter per second square, written as ms raised to minus 2. Hope till this you are clear. Next is momentum. Momentum is nothing but what? Mass into velocity. Mass, everybody knows dimensional formula is m. For velocity we have already derived, that is L1 t minus 1. So for momentum I can club it as m1 L1 t minus 1. Unit for mass is kg, for velocity is meter per second. I can write it as kg meter, because both are in multiplication, second is division, so it will come up as s minus 1. So my unit is kg meter per second. Clear? We'll see next quantities in the next video.